Hello everybody, I am Oussama Ahmia. I am a research engineer at Jurismarché. I am also a member of the team Extraction at the laboratory IRISA. I'm doing my PhD at the University of South Brittany in Van. So I am here today to present you some example of how to use Scikit-learn for text mining. And I will also show you some problems that we can solve using machine learning techniques at Jurismarché. I will start by introducing Jurismarché. After that, I will present you 3 examples of using text mining at Jurismarché. The first one will be Citizen Map, which is a web application that we just launched. Citizen Map won the prize of Data Connection 2016. And after that, I will present you a different example, which is detecting and removing some kind of noise that we can find in public markets databases. And at the end, as a bonus, I will speak about relationship extraction and structured prediction. Jurismarché is an SME based at Nantes, founded in 2005. We are 14 employees. Half of us are computer scientists, and third of us are experts, market experts and analysts. Jurismarché goal is to give to our client business opportunity, helping the development of those companies in the area of public procurement by focusing on the provision of economic environment, knowledge and business. We have a database of 7 million documents about Marcus. About 52K of them require a manual curation by experts, which is actually a difficult task and time-consuming task. And this is why we are using machine learning and text mining to solve this kinds of problem. Call of tenders. Call of tenders is a special procedure for generating competing offers from different bidders looking to obtain an award of business activity or for winning a market. In French, call for tenders are appel d'offres. So let's start with Citizen Map. What is Citizen Map? Actually, Citizen Map is a map that allows us to visualize and follow territory planning in France. What are the constructions that will be done in your neighborhood? Roads, restaurants, parks? Citizen Map is here to answer to these questions. Also, Citizen Map is a tool that allows citizens to comment and give feedbacks on the projects that will be done in their neighborhoods. Also, Citizen Map is a tool for governing bodies to make announcements at the local levels on what are the projects that will be done in French city this next years. How does it work? Using machine learning techniques and natural language processing, the application may autonomously detect territory developments from public database, from call for tenders, commercial authorization, and so on. Knowing that these kinds of database contain a lot of announces of different areas. For example, there is announce about construction, announce about food, about actually IT. This is actually a picture, a screenshot of Citizen Map. I don't know if you can read, but this is a project of constructing a leisure center at the city of Nanterre, which is at 3 kilometers from this place. Actually, you can see that citizens can comment and give feedbacks about the projects. How does it work? To retrieve the relevant projects, the app analyzes the public procurement announces. The process of finding and publishing the projects are done following these 3 steps. The first one is classifying the announces. From a big amount of announces, detect if an announce is relevant or irrelevant to be published at Citizen Map. It's like actually Shakespeare's question, to publish or not to publish, this is the question. The second step is to categorizing the projects. What type of project? Is it a construction of roads? Is it a restaurant? The next step is to transform and summarize the title, because in some examples, the title is often too long or too hard to be understood by non-experts. So we are using some algorithms to actually summarize and transform the titles. The last step is to geolocate the projects. Using some natural language processing techniques, we try to extract the exact address, and after that we can put the projects on the map. I will actually speak about the first problem of detecting if an announcement is relevant or irrelevant to be published in Citizen Map. So let's start with some text mining concepts. Usually the goal of supervised learning is from a training data set, we try to find a function or an estimator. By knowing a vector of observation x, we try to predict a value y. So what are the features that we use for text mining? One of the simplest algorithms is bag of words algorithms. Actually, this is an example of bag of words algorithms using Scikit-learn. Bag of words algorithms consist of making a vector of counting words. So we count each occurrence of a word in each sentence in all the documents. This is an example. Let's say that our corpus contains two documents. The first one is PyData rocks. The second one, you are rocking. Using count vectorizer, this is the results of transforming a text into features. We can see that the features are actually the words. We can notice in this example that rocking and rocks are different features, and knowing that the two words actually have the same meaning because it's the same words actually. So how to fix this kind of little problem? We use stemming. What is stemming? Stemming is the root of a word. For example, for the word fishing, fished, and fisher, the stem is fish. Let's try to do a stemmatization for the past example. This is a small function that I have implemented actually to transform the words into stems using NLTK library, and how to actually implement it and to pass it as an argument to count vectorizer. So here the function will take each word after tokenizing the sentence, and it will find the stem of this word. And if the word is a digit, actually we just put the digits. So this is the results of applying these algorithms to the past example. We can see that rocking and rocks are considered as a same feature. And also doing that, we reduce the dimensionality of the problem. Let's talk about random forest. What is random forest? Random forest is a combination of several decision trees, where each decision tree is built on a subset, on a different randomized subset of the training samples, and this is called bootstrap samples. And each decision tree is built on a randomized subspace, or a randomized subspace of features, which is called actually the random subspace algorithms. With that, we will have a bunch of randomized trees. Combining all together, we will have a random forest. There is some belief about random forest. By doing this kind of randomizations, we can assume that most of the trees can make correct prediction on most of the data. And also that most of the trees will do mistakes at different places with different observation. And this is why actually the random forest algorithms is less sensitive to overfitting. The more trees we will have in our models, the less probability of overfitting will be. At the end, if we are doing classification, we will do a vote of all decision trees to get actually to be the closest to the correct answers. And if we are doing a regression, we will actually just average all the decision trees. This is actually the workflow that we use to design the initial model of citizen map. We can see that we extract the announces, we remove the stop words, we do stematizations. Actually, we have two data sets. A data set based on the form of the words, and the second one is based on the stems. After that, we use n-gram. N-gram algorithms actually is the fact of taking subsequence of our sentence. For example, let's say if we take the word good as features, if there is the word not before it, actually it means the opposite. And this is why we use actually subsequence to get the context of the words. After that, we're doing an entropy-based decision tree in order to select a bunch of features, the most important features, and we will use them in the classifications. After that, we will just create two random forests, one random forest constructed on each data set. So we will have a random forest that will be constructed on the stemming data sets and the other one on the form-based data sets. At the end, we will do the union of the two models. I will explain you why we did that. This is actually the score tables of the models based on the stem. We can see that the precision for the relevant class or positive class is actually smaller than for the negative class. And this is because we had the unbalanced data. We can see that the number of positive example is too small comparing to the negative example. So 12% of 2,000 and for 2K projects that we have labeled to train the classifier, actually it's a lack of example. And the second one is that the data were labeled by different experts. So sometimes we are very similar projects, and one of the experts will be labeling that as a positive one, and the other one will label it as a negative one, and actually this has caused some problems while learning the models. Relevant. So it will be published on Citizen Map. And the negative, he will not be published in Citizen Map. And this is an example of results of title classified by as positive by the stem-based classifier. We can see that the stem-based classifier can detect much longer title compared of the non-stem classifier. And actually this is why we use two classifiers to resolve this problem. Let's attack the second example. We have in call tenders usually a special kind of noise. We have sometimes a part of the annonces that contain only legal and administrative information. And one of our product is G360, which is actually a web app and a search engine where our client can search projects and the business opportunities. And this kind of sentence, while we are doing the indexation of the database, cause a lot of problems and can corrupt the queries of our search engine. So to improve and to resolve this problem, we need to create an algorithms that detect if a sentence is administrative and legal content, or is it just a sentence that gives information about the project. And this is a binary classification. I will show you actually the real algorithms and the real model that we use in production at Jurismarché. And this is pipeline objects. It's a scikit-learn object that allows us to implement machine learning process or workflow. You can see here that with only 4 lines, I can do feature extraction, a transformation of data, feature selection, and the classification. Let's talk about dense transformer. Dense transformer is an object that I have implemented it's inherited from transformer mixing object of scikit-learn. It allows us to transform a sparse matrix into a dense matrix. Because in scikit-learn there is some of the algorithms that cannot take as argument a sparse matrix, which is the case of PCA, principal component analysis. So the pipeline object take as argument a list of tuple. Each tuple contains the name of the step and the object, the transformation, or the classifier. Here we do the count vectorizer, and we transform the sparse matrix into a dense matrix. We use PCA to reduce the dimensionality of the problems, which is kind of feature selection. And after that, using random forest, we do classifications. What is really good with the pipeline is that by using joblib and dumping all the pipelines, we are dumping and saving all these models, all these objects. So for example, if I want to use this count vectorizer in another project, I just load the file, and using named steps, I can load one of these steps to use them in another project. This is actually the results on 1 million observation. Actually, we had 100% good classifications, but we had a problem that we cannot accept false positive. So what we do is basing on the probability predictions of the random forest and using a threshold, we can actually ignore some positive classified objects if they are smaller than, if the probability is smaller than the threshold. Let's start with, let's end with the third example, which is a relation extraction example. We have one problem, or one project. We needed to do a modeling of French cities based on textual description from California tenders. One of our problem is that we can detect the buildings, but how do we know which is the area of these buildings? We needed at a point to link buildings in the text with its respective area or surface. And this is actually what we call, in natural language processing and text mining, a relation extraction between entities. And this is actually a structured learning. Did anybody here have tried to work with structured classification? Good. So structured classifications comparing to classic classification. In classic learning, we have a vector of features, and we want to predict a variable. But with structured learning, we have usually structured objects as input. For example, we can have sentences. In our case, it's sentences, sequence of words. In other case, we can have a graph objects or tree objects. An example of structured learning is the translation problem. We want to translate a sentence from language A to a language B. We have as input a sequence of words, and as output a sequence of words. And the context of sequentiality is really important in this kind of problem. So to solve this problem, we use conditional random fields. Conditional random fields look like actually like logistic regression for sequential data, and smell like hidden Markov models because of the transition between states and the sequentiality. Let's do some theory. The conditional random fields is based on vector of features function and a bunch of weight. We need to optimize those weights actually to do a good prediction. The feature function, as you can see here, is based on the present y and the past y. So actually there is, we have information about the past states or the past vectors, the past feature vectors. And using conditional distribution, we are trying to predict a sequence y knowing a sequence x. This is an example of using the CRF, conditional random fields, on part of speech tagging problems. As we can see, as input vectors, we have a sentence, and as output vectors, we have a list of pause. As you can see here, the feature function is based on the present element and the precedent element. So our approach is to look at the linking problem as a tagging problem. And those are the labels that we use for the relationship extraction. So what we will do is to take a sentence and to tag each word. It can be a BS beginning of a relation, which is a building or an area, the ending of a relation, which can be a building or an area, and the token between the tokens between buildings and area, which is called continuity. And we put tag 0 for all the others tokens that we don't need in our link. This is an example. So in the first example, the model we should have as a result that the area of this room is 200 square meters. So the algorithm should label the word sal as a BS because it's the beginning of the relation, and the word and actually the token 200 square meters as ending of the relation, and all the tokens between them will be labeled by IS. And for the example 2, all the tokens should be labeled by 0, because here this area is not the area of the houses or of the variety of the parks, but it's the area of the global projects. So the algorithms should understand if he has as input an example that looks like this one, he should tag all the sentence with 0. And those are the variables or the features that we use for each token. We are using actually the word to lowercase, a Boolean features, true if the word is in uppercase, or false if it's not. The word is title is also a Boolean features that gives us true if the first letter of the word is in uppercase, false if not. A word is digit, actually it's a feature, true is a Boolean features that actually say if a word is a digit or not a digit. The part of speech is actually the word a verb or an adjective. The second part of post tag, which if we have a verb, is this verb in past time or in future time. CPT says to us if the word is a building or an area or other thing. The lemma is actually, it's like the stem. And the previous and next two tokens, actually we also added for each token those features for the two next tokens and the two previous tokens. This is an example of features for the token for this area. We take all the features described in the previous slide for the token in red frame, and for this one, for the and for bond, and also for utile and for the parentheses. In order to choose the best parameters and the most efficient learning algorithms, we use the grid search algorithms. And to generate the learning samples, we didn't have enough time to label all the data that we use manually and by experts. So what we did is using regular expression, we're generating some links on texts, and after that, some experts will verify if those links are good or not. The best estimators was trained using averaged perceptron algorithms with 180 iteration. Actually, this is the results on 1K sentences, 20% of them for test and 80% of them for training. Actually, those are the results. We had actually 85% of good classification. Actually, we have noticed a thing, knowing that all the training data set contained only one link, with one building with each area. So on all the data sets, after training the models, he could detect even if there is more than one link. Here is an example. He can detect actually that for the word logement, the area is this one, and for the loco poubelle, the area is this one. So let's summarize. At Jurismarché, using machine learning's algorithms, we could resolve 3 problems. The first one is how to detect development projects from public databases and publishing them in Citizen Map. And I invite you to try and to see what is Citizen Map. Actually, it's a free app. The second one is to remove the legal and administrative sentence, which is kind of noise. And this, actually, we will use this in similarity detection between documents. So we will remove all the noise, actually, to get what are the projects and the announcements that are similar in the meaning. The last one was about extracting semantic relationship between entities, which allows us to extract an area of a buildings and after that to modelize a project based only on text data. Thank you for your attention.